Ladies and gentlemen, good day and welcome to another session of Nambane Academy. And today we will be dealing with vertical projectile motion. But before I get into the nitty-gritties of physical sciences, let me just say welcome and happy new year and compliments of the new year to each and everybody that is here. Uh, we should have started at 1700, that is 5 o'clock, but now the key critical challenge was now I will still had to admit other people. So the time is exactly 1707, and just to set down easy ground rules, one where you are noted, I just need to address few things. Kindly keep your mic switched off at all times. Switch off your video, and if there's something that you need to say, this platform allows you now to raise your hand. So because of that, it will allow us to have a system that is operational, the system that will allow us now to operate fully. Remember, once your video is on, it's now consuming what we call the bandwidth and more data. So kindly switch off your videos at all times, switch off your mic at all times. If there's something that you want to say, comment or ask a question, kindly raise your hand and then I will call you out so that you can be in a position of asking your specific question. And one will ask that, Nambani, what is it that you are doing, in a sense of why do you want to assist us? The key critical thing is, with us, the only key way of success is through education. And the history has taught us that now for us to do well in both mathematics and physical sciences, we need to now to start very early. So that's the reason why, as the team of Nambane Academy, we sat down and agreed to say, how about we offer now a free session of about 2 hours to 3 hours. But now somebody just said to me, but Ntate Nambane, it's Friday, and it's Friday where now we are going to start preparing for next week or the reopening of the schools. So how about now we just keep it within 90 minutes to 2 hours? So that is what I'm going to try and do, to try and compress everything in a manner that it is understandable, easy for you to flow. This topic is a topic that is now in grade 12, but it is topic number 2 of term 1. So the idea is, when you get to this topic at your school, you will be somehow ahead because they are going to start with momentum. So I am going to record uh, these sessions in such a way that they are available on our YouTube channel. They are also available on the website, where you can be able now to get the PDF documents. So the recording of this session will be available, and it is currently running concurrently. We are live here on Google Meet. It is also streaming live on our YouTube channel. So the key thing is, we want now to maximize the impact. We want now to give now the full support that you can be able to give it to you. So as a quick reminder, let's keep our videos switched off at all times. Let's now also switch off our mics in such a way that we will be now in a position of communicating fully. So I'm going just to allow one question. If there's somebody who wants to ask a specific question, such that now we know that you can fully hear me, and I believe you do because I did test the system earlier on, just to ask one question before we get now into the nitty-gritties of today. Bikanyo Motlhale, you can open your mic and then ask your question before we proceed to the events of the day.
Hi. Can I ask, is vertical projectile motion part of motion in one dimension or two dimensions, something like that? The first topic in grade 12.
It is part of motion in one dimension. Hence, it's vertical, so it can only be up or down. So with that being said, I now understand that you can fully hear me. So without wasting any time, let me quickly do this. Ladies and gentlemen, there's an attendance register that I have just pasted in the chat. Kindly fill it in. It is for statistical purposes because where I work, we work with numbers. We work with how much impact did we do. So it's just an easy attendance register. It is an online register. So while we are in this session, kindly fill it in. It will be a clear evidence of indeed this session did take place. Ladies and gentlemen, let me not waste your time anymore and get into the science. So getting into the science, like we said, this topic is now vertical projectile motion. So usually what do we do when we work with vertical projectile motion? I always start all my lessons at the center, the reason being I am one person who understands grouping and also understands the approach in a manner that what is the link between the concepts within this specific topic. So first thing first is now to exactly try to explain what now each of the keywords in this particular uh, topic means. One has already been asked, Bigano asked, is now the topic in one dimension or two dimension, but now according to our CAPS document, we can only work now with one motion, a motion in one dimension. So motion in one dimension basically means what? Basically means in this instance, we are only looking at up or downward motion. So it can either be up or down in this instance. So our object that we are focusing on should be now either moving up or down. Hence, it is called now a vertical projectile motion. But furthermore, one can easily say, what is this projectile? Because remember, with now physical science, we are expected to know our definitions also. One key critical definition here will be exactly to say what is a projectile, and this will be assessed for a maximum of 2 marks. So where do I get these proper definitions? What makes my definitions to be 100% correct? The only thing that can give me a proper definition, it's not a textbook. It is not a study and master or any guide that I receive, but we use now what? Definitions as they appear in our exam guideline. So what the exam guideline says is what needs to be written in the exam. Because remember, the textbook can be now explaining the same concept in so many ways. But what we want to do, we want to have a standard approach in terms of what is a projectile for a learner who is doing grade 12. So for that, it means we need now to fully explain according to the CAPS document as well as the terms and definitions that we have. So I am quickly going to write it down. It is defined now as an object which has been given an initial velocity, been given N, initial velocity. Initial velocity, and on which the only force acting on it is the force of gravity. Now, this is the definition given as per the exam guideline. So what does it say? A projectile is an object. We need to get that one right. So a projectile being an object, it basically says it is this object that will be moving up and down. It is this object that will be now moving vertical in our consideration of the motion. So the object is called a projectile, and this object must be now given an initial velocity. But it is true, we need to have this initial velocity for it to start moving. We need to give it now this initial velocity for us to have the motion that we are considering, because it will not move if it does not have the initial velocity. Furthermore, it says, and on which the only force, I must add here that the only force acting on it is the force of gravity. The only force, it's important here to say, the only force acting here is now force of gravity. So the only force acting on it must be a force of gravity. So what does this say? It says even if it has the initial velocity, for it to be a projectile, the only force acting on it must be a force of gravity. So what does this say? It says to me, once I have all these other forces, then it is not considered to be a projectile. For it to be a projectile, the only force, keyword, the only force there must be the force of gravity or the gravitational force. That is when we can consider an object to be a a projectile. So it can only be a projectile provided that the only force acting on it is now the force of gravity or the gravitational force. Furthermore, we move now to the second part of vertical projectile motion. We said vertical motion in 1D, up or down, projectile and object. But what do we call now this motion? This motion that we have as now our number 2 is what we call a free fall motion. But how do we define free fall also? Free fall is the motion of an object under the influence of gravitational force, of the gravitational force. Now let's look into these two words: projectile, free fall. Free fall, keyword, it's the motion. So when I am expected to explain what is a free fall, the keyword there should be the motion of an object. But which object now? This object that is a projectile. So the motion of a projectile, it is known as a free fall motion. So which object are we focusing on here? This object must be our projectile uh, object. So it is the motion of a projectile under the influence of gravitational force. So what is the link between the two? The link between the two is, for me to have a projectile, it must be an object that is now only experiencing the force of gravity. For me to have that motion of this projectile, which is known as a free fall, then it basically says it must be the motion of an object under the influence of gravitational force. So once there's any other external forces, your friction and other forces besides gravitational force, that motion will not be considered as a free fall. With the two explained, allow me now to give you something like 20 seconds for you to digest all these concepts. What is a projectile and what is a free fall? And what is the link between the two? Because once we understand the two, it will become easy for me now to explain the third bullet, the fourth bullet, and the fifth bullet. So I don't want this to be a talk show as if I'm talking to myself. I am giving you now the 20 seconds, and in this 20 seconds, if you have a question, you can raise your hand. Or if you do not have a question, you can just digest these two concepts that I have quickly explained. Thank you very much. I did not see any hands. It basically says now everybody understands the difference now between what is a projectile and what is a free fall. I'm going to further add another bullet, which is be bullet number 3. And on this bullet, I say now conditions of free fall. Conditions of free fall. Very, very important to note. For grade 12 learner, these are important things to look for. For you to consider this as a question under vertical projectile, this condition must be met. The first condition there should be ignore the effects of friction. Ignore the effects of friction. Very, very important. Ignore the effects of friction. Also look for keywords such as no friction. Anything that says no friction, frictionless, all these keywords allows us to have a condition for a free fall. So it says if I have all other external forces, that motion will not be considered as a free fall. That topic that I am working on will not now have the implications of a projectile as an object. So that is very, very important. So What will be the other important condition to note or to take note of? The force acting on an object must be the gravitational force. Only force acting on the object must be gravitational force. Must be gravitational force. If it is not gravitational force only, then it means we are not in a free fall. It means we are not working with a projectile. But that Nambani, if that is the case, and we say the only force acting on this object should be the force of gravity, can we be in a position of drawing a free body diagram for this object when it is moving up or down? Of course, we should be in that position to say, let's draw now a free body diagram for this particular object. So now I am going to give uh, another 15 seconds in order for us to now try to draw a free body diagram by only understanding that the only force acting on this object, it is the force of gravity. So whether it is going up or down, there's only one force acting on this uh, uh, object. So I want you now in our chat just to quickly just send me the direction of this force. Is it up or down? So I am quickly going now to request you to send your answers in the chat quickly by just saying what will be the direction of this force. Is it going to be up? Is it going to be down? So I am going to give you 15 seconds in order for me to take now those answers. Quickly do it and then let's get the answers. Just write now in the chat up or down, and then we will discuss and draw the correct one immediately. Thank you very much. I got answers. Most of the people said it is down 100%. So we are going to draw a free body diagram. Gravitational force is always now acting downwards. So hence we have now our FW. So the emphasis here should be what? Should be whether it is moving up or down. The only force acting on this object is the force of gravity. And the direction now for the force, which is the gravitational force, will be downward. So regardless of whether the object is moving up or down, the free body diagram will remain the same. So this is now the key concept that I wanted us now to try and explain, to try and be in a position of fully understanding. But now, if this is the topic itself, and these are the four critical bullets that we need to know, can we add one other critical bullet, which will be number 5? Let's add it here, which will be number 5. And number 5, we say the magnitude magnitude of G. The magnitude of G. What is G? G is the gravitational acceleration. So we need now to know what will be the magnitude of G in this particular topic. So the magnitude of G will be given and it will be a constant. So how can I refer and know this? I need now to consult my data sheet. It will be given. So for the next 15 seconds also, kindly give me what is the value of G in the chat platform. Thank you very much. Answers received. Most of you are saying it is 9.8, 9.8. But now, this is what I wanted to check. Remember, when we work with a magnitude and we work with vectors and we work with acceleration in this instance, it is always critical to give magnitude and the SI unit, because we penalize you now for just saying it is 9.8. What is 9.8? It must be acceleration, which is 9.8 meters per second squared. So because of that, then we are in a position of saying 100% this should be correct, because if you say 9.8 without the SI unit, we do not award a mark. Therefore, we want to say what will be the direction of this acceleration, because acceleration is a vector quantity. Is it going to be up? Is it going to be down? But remember, what will be the influence of what we have? The answer should be in relation with our free body diagram. So for the next 15 seconds again, what will be now the direction of the gravitational acceleration for the next 15 seconds? Thank you very much. Answers received, then it must be downwards. So these are some of the questions that they ask in an exam. These are some of uh, easy questions that we expect to get a maximum marks, but we need now to understand these basic concepts. So with these basic concepts, it allows me with high level of confidence to say I can move to other complex or more interesting ways on how to answer this specific chapter. So I am going to give you no time for you to digest, because we've been active in terms of what we want to do in terms of explaining now these key critical concepts. So let's further move on. What is written here is motion, and we usually say these are equations of motion. Equations of motion. So this will be given in your data sheet. And these equations of motions are the equations that we are going to use to solve problems related to vertical projectile motion. But there's one thing that I want us to emphasize and look into. V, I, VF, A or G in this instance. Let's use a G, and delta Y. All this are now vectors. What do they mean when they say they are vectors? It means they have magnitude and direction. So it basically says I am going now to be forced to always have a choice of direction. Upward as positive, downward as negative. So when working with these physical quantities, VI, VF, G, and delta y, because we are now focusing on a vertical motion. They are vectors. So the fact that they are vectors, it means now they must have both magnitude and direction. So we must have now both magnitude and direction. So because of that, I must be forced to choose a direction. Because of that, I cannot do a problem that relates now to projectile motion without actually having chosen a specific direction. So for all the calculations that I am going to do, in most cases, the direction that I usually say I choose now my upward as positive. I usually do that. It makes my life somehow very easy. But remember, this is science. This is not cast in stone, because with science, we allow you to have your critical way of thinking. But this is the approach that has worked for me. This is the approach that assisted me to somehow make things easy, even if I'm in a position of getting high level of complex question. The fact that I'm going to choose upward as positive, somehow I saw that everything becomes now nice and easy for me. So with this being said, it says to me, when I have VI, VF, G, and delta Y, the choice of direction should be very important. And because of that, when I check, I'm going to name these equations or number them. I'm going to say this one is equation 1, this one is equation 2, this one becomes 3, and this one becomes 4. So I want us to shift the focus to equation number 4. Equation number 4 says delta y is equals to Vi plus Vf divided by 2 multiplied by changing t, where t is just a scalar quantity. But what is my concern? Wipilo, kindly stop sharing your screen, because now you are disturbing my screen. Thank you very much. Let's stick to the rules, and the rules are clear. No sharing from your side. Your videos must always be off, and your mic must also be off. Thank you. So with that being said, I want us to look at equation number 4. Equation number 4 says delta y is equals to Vi plus Vf plus or divided by 2 multiplied by changing t. This equation number 4, for the purpose of projectile motion, I want us to sketch it out. And then one will ask, but why Ntate Nambane? Because if you check all other equations, equation 1, we have A4 that will represent a G. Equation 2, we have A that will represent a G. Equation number 3, we have A that will represent a G. So let's go back. If we go back, we agreed For us to talk of a projectile, it must be an object in which has been given an initial velocity, and the only force acting on it is the force of gravity. And force of gravity is now related to gravitational acceleration. We further went to say, let's consider when we are told the object is in a free fall. It is the motion of the projectile or an object that is under the influence of gravitational force. Gravitational force which will be influenced by the gravitational acceleration. So when we check equation number 4, it does not accommodate the g. So if I work with a projectile motion, I will try by all means to avoid working with equation number 4. The reason is that equation number 4 does not accommodate the g. At times it works, at times it does not work. But I want us to create a system, a foundation that will assist us to say 1, 2, 3 equations are the most probable, high probability correct equations that one can be able to use. So I am just explaining this. So I'm going to give you your 20 seconds for you to digest this concept, and then I will further build on it. Remember, the 20 seconds is if you have a question, you can raise your hand and then we attend to it. If you don't understand a certain concept, then you digest everything that has been said on the slide. Thank you very much. I don't see any hands, so it says indeed everybody understands. So let's look into these equations again. All equations have about 4 variables. Let's look at equation number 1. It's 1, 2, 3, 4. Equation number 2, 1, 2, 3, 4. Equation number 3, 1, 2, 3, 4. So it basically says because of this arrangement of the equation, somehow I can be in a position of using them correctly. How best can I use these equations? Now, hints on how to use these equations. First things first, draw a sketch diagram. A sketch diagram for the problem given and label it all the important sections, all important parts of the motion, all the important parts of the motion. Let's explain. Draw a sketch diagram. So in an exam, you'll be given the STEM, which is the statement of the problem. An object was thrown vertically up, it was thrown downwards, so we need to have that specific sketch. Why do we need to have this sketch? This sketch is going to assist us with the important parts of the motion. Because with physical science, I usually say if you can redraw it or reinterpret it from the question paper, it basically says it gives you now 70% chance of getting it correct. So redrawing the sketch, of which this sketch We usually call it the trajectory of the projectile. If you can draw this trajectory, believe you me, you will be in a position of exactly understanding the parts where the questions are going to come from. It basically says from the sketch, you can easily understand or foresee the questions that the examiner is going to ask. Furthermore, write down the given variables. Write down the given variables. So, what are the given variables? It is your V final, V initial, delta Y, time. It will just depend on the information that has been given. So write down the given variables. So I am going to highlight here to say some variables will definitely be given. Now, here comes the trick that most people are not aware of. We only need three variables. Only need three variables to perform a calculation. To perform a calculation. So we only need three variables. Only three. So if we can get these three, then it means I am done with the science. But it is not that easy to get these three. Why? Because two variables will always be given. Two will be given. 100%. It should be clear and straightforward. So if you can get that true from the statement, it means now we need now one variable. So where is this one variable? I'm going to highlight it and change the color to purple for the purpose of emphasis. This one variable is hidden. It is there, but it is hidden. So if it is hidden, what does that say to me? It says, okay, fine. I must apply now physics principles. So apply physics principles. And what are these physics principles? It's very easy. You will see when we try to apply these physics principles, some information should definitely be clear in terms of which principle can one apply. So my emphasis in terms of answering the questions, one should be in the lookout for these two variables that will be always be given. Always given. But the science starts now when we are in need of this other one. So only three variables we need to perform the calculation. But the two will be given. But the one is given but hidden in the statement, hidden in the science. So the principle here is let's start by the two that is given and now look for the one that is hidden. Once we are in a position of doing that, believe you me, everything thereof should be 100% correct. Everything thereof should be clear in a sense of how to perform or which equation now to be able to choose. So after all that has been done, remember now, you must now choose a direction. Choose the correct equation. Choose the correct equation. And how can we choose that? The variables given inform us in terms of the correct equation. Already I am now one step closer to getting it right, because I know for sure, definitely, with high level of confidence, that the equation that I am choosing is 100% correct. The reason being, I am given the two variables, and I have also indicated that I must get now this one variable that is hidden. Remember, all these hints, A, B, C, and D, they go hand in hand with the choice now of direction. Remember, choice of direction is very, very critical. It's what basically governs everything that we are going to do with equations of motion. So because of these key hints, the science is going to start now becoming very, very easy. How does the science become very, very easy? Projectile has been divided into different sections or different types. So I am going to start by what we call type 1 problem. I did not compile any questions or exam type of questions, because the idea was to explain the concept. The mistake that we do is we want now to answer question papers, previous question papers, without actually understanding the critical concepts or the basic foundation of each topic. So if it is not asked in the question paper that you are doing, it means you did not do it at all. So hence the idea today is, let's just focus on explaining in detail the science behind the projectile motion. Because once the science and the foundation is correct, building on with different types of questions, it becomes now very, very easy. So now that I have done and explained how best can you choose the correct equation, drawing of the sketch, what is it that you need to look for, it means I can only be in a position of giving you now your 30 seconds for you to digest, ask questions if there's any, and then in this instance, we will proceed to type 1 of the examples. Thank you very much. I don't see any hands. It means now we are clear in terms of how to approach the equations of motion, and also how best can one uh, understand the diagrams or the sketches given thereof. So I am quickly going to add a new page, and in this new page we are going now to say we are starting with what we call type 1 problem. But what is this type 1 problem? The general principle is, at the end, what the examiners do, they just combine all these types into one. So I could not take one question paper, place it here, and do that, because one concept feed into another concept. So I'm trying to build a solid foundation such that we definitely know that when all the types are integrated, then we definitely know what to do. But what is type 1? Type 1, it says object dropped from a height. So we have an object dropped from a height. So let me quickly draw a height of the building. Let's just fill it with black. Okay, fine. And then we can now easily say if this is the height of the building, this is now the height of the building with an unknown magnitude, and then I have this particular person standing at the top, and then this person is going now to drop this object. Now we must understand the science. What is the science? The science is the object is going to move into this direction. Let me use proper. It is going to move into this direction. That we know. And we know for sure it's going to cover this specific distance. What else do we know? We know that g is a constant, which is 9.8 meters per second squared. What do we know about an object that is being dropped? The v initial is equals to 0 meters per second. So this 0 meters per second, it is important for us to understand that when the examiner tells me that the object has been dropped, its initial velocity is equals to 0 meters per second. If it is also released or discharged, all these keywords are the keywords that are telling me that v initial is actually equals to 0. But what is it that the science is telling me? The science is telling me that if this object now is moving from 0 to this point downward here, so I am going to say my top point is A and my bottom point is B. Where does this A and B come from now? They come from drawing the sketch. They come from understanding the science. So A and B are the most important points that I am going to be looking at. So what does this say to me? It says to me, I am going to start with a velocity of 0, and as I move down, the velocity is going to increase. So what does this say to me? It says now v at B is greater than v at A. And why is that the case? Is that the case because now we have now our object? Why is that the case now? The case is we have our object accelerating downwards. So our object is accelerating downward. So I can check myself already to say if I am calculating at point B, then my velocity is smaller than the one I started with. It means the science is not correct. Can I have an analogy that one can use? Yes, I can have an analogy which I call window. What is this window? Velocity increases when the projectile is moving. So the window assists me to know and check, especially when I'm working with multiple choice type of questions. So velocity increases when the projectile is moving downwards. So the window is for understanding that velocity increases when the object is moving down. Can I apply the same when the object was going up? Of course, it should be now the other way around. So when we do type 2, we will understand why we need to have the window as our analogy. The window is just for velocity increases as the object moves down. So this is going to assist us when we even draw the graphs of motion. Now, with this information being said, I want us to try and draw three different graphs. I don't have questions. I don't know what the examiner is asking. And I am not going to do that because remember, the idea is to explain the concept, not to perform the calculations. So once the concepts are done fully, then I am very happy because even when you move after this session and you get a question paper, you get a multiple choice, you will be in a position of saying something related to that. So I want us now to see if this is the information that is given. And from this, can I be in a position of drawing the following graphs? A, can I draw position versus time? B, can I draw velocity versus time? C, can I draw now acceleration versus time? It's just easy concepts that I want us to look in. And from this statement, without any values whatsoever, can I draw now all these three graphs? And in this instance, I only have downward motion because it is dropped from a certain height. What can I do? I can easily say I am choosing now my downward as positive to make my life now nice and easy. So I am going to start with A, which is position versus time. And this is position in meters, and this is just my time in seconds. So what is it that is happening here? What is it that is happening? It basically says everything here should be positive. So it is going to start at a certain height, which now at A, where is our starting point, which will be a 0 point, and then it will move to point B, which will be our maximum height. So it will move into this particular, let me draw it the correct way. Then there it will be our point B, but we will know it took now a certain time, which is maybe t1 or t2, for it now to complete this particular motion. Let's move now to velocity versus time. So this is velocity versus time in seconds also. Now, at point A, what do we know? A must be there where Vi is equals to 0. Hence, the slide that passed says to indicate all the important parts of the motion. So hence, I am confidently in a position of labeling A and B. So if I was not in a position of having this diagram, the sketch, then it means my information will be just loosely around. So it is important, according now to the hints that we shared, to have your A, B, C, and D, depending on the information that is given. So now let's check. For velocity versus time, we are starting at 0 and it is moving downwards. So downwards is positive, so everything is going to be positive there. Then it means I must get a straight line, and then there somewhere it is going to be our B point, which is true. Then we get our B point, but it is going now to do what? To complete this at a specific given time. Can I do the same now for acceleration versus time? Of course, I can. And my G will be positive because I chose now down as positive. So everything is positive. What do I know? I know that the value of this must be 9.8, and everything there, it must be constant throughout. Let me use a correct line for the purpose of clarity. Then if this is the case, then I just know that this is my acceleration and this is my time in seconds. So I did not use any calculations, but the fact that I understand the science, the fact that I am in a position of ensuring that every little detail that is here, from the sketch to the calculations, from the sketch to the graph, and also it is easy now from the graph to move into the sketch. So take your time, ask questions on basically type 1. Let's have that interaction in terms of everything that is now on type 1 type of a problem. So if an object is dropped, V initial is equals to 0. G remains the same throughout because we said that object is going to experience a gravitational acceleration of 9.8 throughout uh, its motion. And then we now came with an analogy of window. The analogy of window is what assisted us in terms of understanding that actually when an object is moving down, the velocity increases. So velocity increases when an object is moving, it's moving down. That is the reason why we came up now with this nice analogy of window. So these are analogies that will assist us when we get to the multiple choice, when we get to uh, the science of why is this one increasing and so forth, the drawing of the diagrams and the drawing of the graphs. It will assist because we will know exactly that every time when my object is moving down, somehow its velocity must increase. So ladies and gentlemen, with that being said, on type number one, I am quickly going to give now us the 30 seconds to digest, ask questions, raise your hand such that now we can move to type 2. Thank you very much. I don't see any hands. I'm just asking myself, is it that I'm explaining everything in detail, or you just don't know what to ask? As a quick reminder, I have just sent again the link to the register. Please fill it in. It's the same link. If you have filled it in, no problem at all. But I can check here also if we have responses. We have only 11 responses, but in this meeting there's about 43 of us. So please, ladies and gentlemen, kindly complete the register. It's very important for us to have that. So we are 43 in here now, so the expectation is at least 43 of us must complete the register. It will not take you long. It's a very short register. It's just your name, your school. If you're a teacher, then you just say teacher and then your province, and then how did you know about us, and then your feedback of the session up to this far. So it is in the chat, so kindly fill it in. So let's move then to type 2. Let's move then to type 2. I'm just getting worried that you guys are not asking questions, but with that being said, let me not waste any time and go straight into type 2. So type 2, remember in an exam, it can be a combination of type 1, type 2, type 3, but it is important to understand type 1 such that you can see type 1 inside type 2 or type 3 type of a question. So let's start. Type 2, they say now an object thrown up from a point and caught at the same point. At the same point. Can you draw a sketch for this? We should, because remember, bullet number 1 under the hints, it says draw a sketch for the problem given and label all the important parts of the motion. So from the statement only, which says an object thrown up from a point and caught at the same point. So we should be in a position to draw that. Let's see if we can. It is starting at this point. Let me choose the right pen. Sorry for that. Thrown up, comes back to the same point. An object is thrown up from a point and caught at the same point. This is the sketch. It went up, returned from the maximum height, went down, and it reached the same starting point. And reached the same starting point. Now, we must apply the science here. What is the science? The science says let's label all the important parts. Let's label all the important parts of the motion. What do I have? I have V initial, but it is now moving up. And the analogy of window, I must write it down again. The analogy of window says now velocity increases as the object is moving down. But the object from A to B, it is moving up. So what must happen to our velocity? It must decrease. So as the object is moving up, our velocity decreases. So if it decreases, it means it's going to move from A to B, and now here at maximum height. At maximum height, V is equals to 0, because it is not going to be able now to change direction if it did not stop. So the analogy now is assisting us to actually apply the science the correct way. But what will happen now from B to C? Window is applicable also. Velocity increases as the object is moving down. So B to C, it will start at 0 and move to a certain velocity, which will be V final. Let's move now. We have this time taken here. I will call it T1. And we have this time taken here. I will call it T2. I will also say we have delta Y. I will also say we have delta Y2 and delta Y1. Now I am going to explain everything here. Starting at A, we are explaining the important concepts of science. We are not doing calculations whatsoever, because calculations needs now this important information. So let's move. I am going to say from A to B, from A to B, from A to B. That is the reason why we said let's identify the most important parts in the motion. If you don't do that, then you are not telling the examiner where you are. If you don't do that, you are not assisting yourself in terms of getting all the important variables thereof. So what do we know? V initial should be greater than 0 meters per second. Why? Because we are told that it is thrown up. So for us to throw it up, we must give it an initial velocity. It is not dropped, hence we need now to give it an initial velocity. So V initial is greater than 0, but decreases as the object approaches B. And we did say that because it's moving up. But now, what is happening at B? I will say now at B, it is now at maximum height. So at maximum height, V is equals to 0. V is equals to 0 meters per second. What about G? G is still the same. It is 9.8 meters per second squared. Now, in this instance, we have up and down motion. So what must we do? We must tell the examiner that we choose now upward as positive. So by saying that, then we know that our G should be negative. Let's further move on. From B to C, velocity increases. Velocity increases towards C. It is increasing towards C. And how do we know? The analogy of window. Now let me put a line here just for the sake of demarcation. And now I am at C now. What will happen at C? V initial is equals to V final. Why? Because of what we call symmetry. They are symmetrical. So it will take now the same V initial at C will be the same V initial at A. So this reason is now because of symmetry. Displacement is equals to 0. I repeat, displacement is equals to 0 meters. Why? Because we are going to have now delta y 1 minus delta y 2. But we did say that delta y 1 is equals to delta y 2, but just now in opposite directions. Because of that, then we get our 0 meters. But distance, I must emphasize, distance is equals to y1 plus y2. So distance is maximum at C. It is maximum at C. So now check what is it that the examiner is asking. If the examiner is asking for the displacement at C, then the displacement must be 0. But if the examiner is asking about the distance must be a maximum. What do we mean by maximum? You just add y1 plus y2, it will give you the maximum. Furthermore, at C, we can say now T1 is equals to T2 according to symmetry. So the time taken to move from A to B is the same time taken from B to C. But what about the total time? Then we say total time is equals to T1 plus now T. That is very, very important. Very, very important. So before I go to the graphs, I will just give you the 30 seconds to digest and move now to the graphs of type 30 seconds should start now. Thank you very much. And the 30 seconds has completed. So I received one question from Lincoln Mbele. Says, Mr. Nambane, can we get this live session or lesson even after the presentation? Because on our side it's a load shedding. No problem at all. Remember, the session is being streamed live on YouTube, and there's also a link to our WhatsApp group for grade 12 in the description. I want to believe so, or I will just maybe share it here also, such that you can join the group, and in the group I'm going to send now the PDF of this session. So you will get the PDF. The video will be on our YouTube channel, that will be just Nambane Academy, then you can watch later on, because I do understand that at times it's issues of data and everything like that, but it's always nice to be in this session because you'll be able to ask questions. So check the description. I will also send the link here for you to join my private grade 12 WhatsApp group. Is where now I send all this new material that I get from other colleagues of mine. The summaries that I do, you will also get from there. So I'm going to add that now very soon in the chat. You will just be in a position of Let me just open another, just to get the link to the WhatsApp, because if I don't do it now, I'm going to forget and there will not be a way for you to actually access it. So I'm just going to go and open my WhatsApp. I will send it now. Thank you. So that is basically it with uh, type 2, but we must also have the graphs for type 2. So can we draw the graphs? We should, because graphs are part now of our syllabus. So I'm going to try and copy everything. I'm going to try and copy everything such that I can draw the graphs on the other side. So let's copy this. And draw the graphs thereof. Just waiting for the system to respond on my side. Thank you. Then let's draw velocity versus time, or we start with position versus time. So let me remove all this so that we can start now with velocity versus time. Let's start with velocity. Okay, position versus time. So A is position versus time. And this one is going to be very easy. This will be my A. It will move from A to a certain point, and this point must be B because it is the maximum point. Come down to this point, and this point now must be C. Hence, it is important to label your charts or the sketches given. Then this here, I know it should be T1, and there at some point it must be T2. But my sketch is not so good because we agreed that T1 and T2 must be the same. So this will just be my maximum height. Can I draw now for position or velocity versus time? Definitely I can. Velocity versus time. Then we agreed that we choose up as positive. So it is going to start here because we set it now A. I'm going to write it as A. V initial, it's now greater than 0. It is not at 0, but it is greater than 0 because we gave it an initial velocity for it now to reach the maximum height. So it is going to move now. Let me have a nice arrow here. It is going to move from here into this particular direction. So let me have it there, and then I will use a red pen to be able to explain the parts. Remember, what did we say? We said now V initial increase is greater than 0 but decreases as it approaches P. And we did say at maximum height, V initial is equals to 0. So what is this point here? This point is my B, and this B, it is now at maximum height. So my graph must also represent the sketch. The sketch must also give me information on how the graph is going to look like. But what is happening now from B to C? From B to C, it is changing direction. It is moving downwards. So this now must be point C. And this there must be T2, and this one must be T1. And everything here must be velocity in meters per second. So this is now explained in a manner, in a fashion that the information we have also relates to the diagram. The diagram we have relates to the graph. From the graph, we should also now be in a position of answering the questions or redrawing exactly what happened. But what does this mean here? It means you'll also have our C here. So hence we said at C, V initial is equals to V final. So if this V initial was 5 meters per second, this will just be negative 5 meters per second, just in an opposite direction. So because of that, ladies and gentlemen, this allows us to have a clear understanding of how we are going to work with the graphs, with the information that is given. This is the science that I want you to have. This is the science that I want us to comprehend and use every time when we have problems to attend to. I am aware that every one of you was expecting calculations, 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 but now we are drawing graphs without any information. We are drawing uh, projectile motions, the sketches, without any information being given to us. So when we do exam type of questions, it's going to be easy because you are going to be given values to calculate and just now to change in terms of the scenarios and situations we have. Can we draw now for acceleration versus time? Of course we can. Acceleration versus time. And we said our direction is upward, so G is upward is positive, so G is always downwards, so G must be negative. So I'm going to have negative 9.8, and I'm going to use just a straight line for that, and this will be my acceleration versus time. So this will be my acceleration versus time in now seconds. Time now in seconds. So ladies and gentlemen, this session has taken more than the 90 minutes we expected. But we did type 1 and type 2. I am very, very happy with that. And remember, this was just a free session. For such sessions, we usually have our grade 12 sessions on Monday and Tuesday at 6 o'clock to 7:30, and then another session on Friday, same time, which will be 5 o'clock to 6. So I don't want to give you a lot of information at the same time, because I want you now to have this PDF, comprehend everything, and after comprehending everything, understand now the basic concept. Then it will be easy to move to type 3, type 4, and type 5. But for now, I think this should be enough. And I would like to say thank you very much for the support. Tell a friend about us. Feel free to contact me anywhere on all the
Thank you.
platforms that we have, such that if you want now to be a part of our daily sessions, then you can be in a position of uh, being attended to. So I am going to take comments, reflective sessions, in terms of how was the session, where can we improve, and the link to the WhatsApp and everything like that. So the link to the WhatsApp, while I'm taking questions, I'm going to prepare it and send it to the system here so that I can be able to what's the word, to share it with you. So if you have questions, kindly uh, what's the word, raise your hands. And even if it's not questions, just give me a reflection in terms of the session. How can we improve, and a way forward. So I'm going to start with Tabisa Boto. Tabisa, your hand is up, so you can start opening your mic, and then I will take others as the hands come. You can open your mic. Okay, Tabisa doesn't. Okay, you just said I enjoyed the lesson, sir. Thank you very much. And Hausa said the lesson was informative. Retabila, thank you, sir, for the time and efforts. Very much appreciated. Thoroughly enjoyed the pace at which you work. Thank you very much. We can only appreciate. I see there's a hand from Lonwa Bombole. Tatembole,
That number.
how are you, sir?
I'm very good. How are you, sir?
My brother, I can't complain.
All right. No, thank you very much for the session, sir. I'd like to start there. Thank you very much for the session. It was informative and you summarized everything. But I just have one concern that I would like you to just clarify for me.
Yes, sir.
If you go back to type one question, the type one, I think it's slide number 2 on
Okay.
your slides.
Type 1.
Yes, type one questions.
Yes.
The graph there of position versus time graph,
Mm,
right? Now, let us assume that object was dropped like 20 meters above the ground.
mm,
Now, let us look at the graph there.
mm.
The graph there, it starts A, position A, which is 20 meters above the ground, starts at 0. I think that's where my concern is.
Okay.
I'm a little bit confused there, sir. Yes, sir.
All
Please
right.
clarify that.
Remember, in this
Mm,
instance, thank you very much, Ntatembole, for that question. It's very, very nice,
thank you.
because that is where most people have a problem. Let me redraw another one just to have
Right.
a comparison of the two. I'm just going to squeeze it in here. It should
Okay,
start
sir.
there at, let's say, A, and move down now to B. And this will be your 20 meters, as you say. So now remember, it comes to a point of a reference point. Are we using the height of the building as a reference, or are we using the ground as reference in this instance? So in this instance of the one that I drew, we say here now height of the building as reference, as
Okay.
reference. That is the reason why it will move as if it is increasing, because at A we are considering it at S0. But now
Okay.
if we are using now ground as reference,
Right.
ground as reference is then that now we need to look into where was the object above the ground. So the two
Mhm.
are now the same, but it depends now on which reference point are you
That's correct.
considering.
Thank you, my dear.
Thank you very
Thank
much,
you very
sir.
much.
Thank you, Ndate.
Thank you.
Uh, I'm still preparing the link. It should be in for the WhatsApp. Wait. Very informative as always, Mr. Nambani. Do you have FSAG for 2023? Yes, sir, I do have, but I cannot distribute as early as now. You'll probably get very soon, and Tatembele, thank you very much. Let me take Memam Popepenene. You can open your mic, Memam Po.
Good evening, ladies and gentlemen,
Good evening, Me.
and Happy New Year. Thank you very much, Ndate Nambani. Ndate, I'm very grateful for the presentation.
Thank you very much, Me.
Yes, it's highly appreciated, Ndate.
Thank you very
May
much,
you
Mebe.
be given more strength and more days. May you be blessed with a long life so that you can assist as many people as possible.
Thank you very much, Me. I always strive for that.
Yes, Ndate. The challenge is that I thank you, sir. I don't see the link for the attendance register.
Okay, let me resend it. I just sent the link, guys, of the WhatsApp group in the chat. You can just press on it and then it will automatically send you to that. So I'm going to send the PDF notes of this session in that particular group. And
Which group,
Mepepenene,
sir? Which group is it?
uh, I have a special WhatsApp group for people that are part of the Nambane Academy, mostly learners. I think Ntatembele is part of that group also. So it's where I share things that are not, what is the word, that are not prescribed maybe for us to share in the group of physical science, but I actually send it now to learners. Like basically these notes that I'm going to share of this lesson, it's notes
Oh,
that are focused on learners having them, not necessarily the teachers.
oh, I humbly request you to add my number.
Okay, I will do so, ma'am. No problem at all.
Okay, thank you.
Thank you. Any other comments, ladies and gentlemen? It's 18:49, and I want us to close this session with one more person who wants to say something. Mr. Msalamadise, I think you are here, so you can say some few words, and then we can close this session the right way we can.
Okay, no, yes, sir. Thank you, sir. So I just want to say now, sir, like, thank you for the opening of our grade 12, sir, for grade 12 journey, sir. We really appreciate this lesson you gave us today, sir.
Thank you very much. Ladies and gentlemen, I will keep this meeting running for the next 10 minutes until 7 o'clock. The reason for that is if I close now this meeting, you will not be able to access the link to the chat. You will not also be able to access the attendance register. So let me quickly check. I have 36 people that have completed the attendance register. Thank you very much. And the people that are joining the WhatsApp group, the link is also there. So from me to you, ladies and gentlemen, thank you very much. Those that have joined the academy, remember we have a session of grade 12 on Monday that will be at 6 o'clock, and then further more details will be discussed in our groups. And remember, you can further extend the the invitation to grade 11s or any other one who is in grade 12, because the idea is to maximize the support, is to maximize and also to try and multiply, because the idea is I am sitting now in my house, but I am reaching people as far as Gauteng as I am checking here in our attendance register. So that is very, very important. And that is what we intend on doing, using the ICT to multiply and to be in a position of assisting all the people that you can be able to do so. So, ladies and gentlemen, I want to emphasize again, we have type 3, type 4, type 5 right now on our YouTube channel. Just check under playlist, subscribe, check there that it says vertical projectile motion. I think we have about 7-8 videos. Then you can get type 3, type 4, type 5 for you to go through. If not, then you go to Nambane Academy and then .com, and then for nambaneacademy.com. Okay, maybe I should open that for you to be able to see, because explaining a website without seeing it, it gets somehow complicated. Stop this one and share this one. Share this one. Thank you. So this is our website, nambaneacademy.com. So when you get to nambaneacademy.com, you get your ATPs. Datembele asked about ATPs, that is the teaching tools. It says in Datembele 2023 ATPs and Free State Assessment Guidelines to be uploaded soon. So I do have, we are just waiting for the go ahead from the provincial office. Then we have content material, but what I'm interested in is learner support material. Ladies and gentlemen, with learner support material here, I have created this nice index. Let me enlarge it for you to be able to see. I have created now this index. So this index is basically the index of all the lessons, grade 10, 11, and 12. So these are all the video lessons we have. So if you can't find anything on YouTube or under Nambane Academy for what reason, you can just come to nambaneacademy.com, learner support material. Then you can have lesson 1, 2, 3 under momentum. You can have lesson 1, 2, 3, 4, 5 of vertical projectile, and I think there's 6 including the one of today. So it basically says all the topics of grade 12, 11, and 10 are here, that now you actually do not need to have me presenting lessons all over again. You can have this, and then I will just modify, ask your questions, and then I will attend and help you the best way I can. So with this, it's an index that I thought if I can have it there, even if the great Lord can remember me tomorrow or later tonight, then you will still have my voice where you can be able to see and check how I have been doing the science and trying to share all the skills that God has given me. So visit the site. We have now even question papers. So with question papers, you get all different sets of question papers for both physical science and grade 10. You go to download, you'll get those things. Then we have dates now there with important dates. I have incorporated our provincial dates here. So these provincial dates, it's things that you will see. If you are going to write a test on a certain day, it will appear here. So for January, there isn't much of things that are happening. So colleagues and learners, this is just a platform that I thought if I can share with you, you will be in a position of fully understanding the approach that I want to take, the approach of full-blown ICT and hybrid learning. So, ladies and gentlemen, with that being said, thank you very much, and may the great Lord give you the strength and the desires of 2023. And let's meet again in the near future. So, from me to you, thank you very much and have a lovely evening.